Welcome to the Power Tech podcast, where we discuss all things related to power supplies and power management. In our last episode, we introduced power converters, what they are, and what's inside of one. In today's episode, we're going to dive into the topic of what to consider when selecting a power supply for your application. We'll also touch on EMC, electromagnetic capability, or compatibility, and its role in power supplies. So let's get started. There are several key factors to consider. The first is the input voltage and its frequency. You want to make sure the power converter you choose can handle the input voltage and the frequency you're working with. Next, you want to consider the output voltage and current. This will depend on the specific requirements of your application. Another important factor is efficiency. Look for a power supply with a high efficiency rating, as this will help minimize power losses and reduce heat generation. It may also simplify thermal design. Additionally, you want to consider the size and weight of the power converter. If you're working on a mobile application, you'll want to choose a converter that's compact and lightweight. You also want to consider the operating temperature range to make sure your power converter can deliver the required power at the ambient temperatures of your application. Finally, you'll want to consider the cost of the power converter. Sometimes it's tempting to choose the cheapest option, but it's important to remember that you often get what you pay for. Investing in a high quality power supply may save you money in the long run. Higher cost power supplies tend to use higher quality components, which increases the reliability of the converter. They also tend to quote higher NTBF rates. NTBF is the mean time between failures, as in the average time for a failure to occur. They also tend to come with a variety of protection features or circuits, such as overcurrent protection, over and under voltage. High-end power supplies also tend to be digitally controlled, allowing for the set points and parameters of the converter to be adjusted on the fly in the field or to be remotely viewed and controlled. Many applications may not require this, but it's a nice feature to have. So you might be able to save some money by selecting an alternative without this option. To summarize, remember to consider the input and output voltage and current, the efficiency, the size and weight, the operating temperature range, and the cost of making your decision. Let's move on to EMC and power supplies. So EMC refers to the ability of a device or a system to function properly in its electromagnetic environment without causing or being affected by unwanted electromagnetic interference. One of the main concerns with EMC and power supplies is that they can generate electromagnetic interference, EMI, that can affect other devices and systems. This is especially true for devices that use switching power supplies, which use high-frequency switching to convert the AC power to DC power. These switching power supplies can produce high levels of electromagnetic noise, which can interfere with other devices and systems. To prevent this interference, power supply manufacturers must design their products to meet certain EMC requirements and standards. These standards can vary depending on the application and even the location of the power supply, as in what country it's being used in. For example, in the United States, power supplies must comply with Federal Communications Commission's regulations, while in Europe they must comply with the European Union's EMC directive. So how do power supply manufacturers ensure EMC compliance? One of the main ways to do this is through the use of filtering and shielding. Filtering involves the use of capacitors and inductors to remove unwanted electromagnetic noise from the power supply's output. Shielding involves the use of materials like metal to block the electromagnetic interference from entering or leaving the power supply. An example of this would be a metal enclosure around a power supply. Another important aspect of EMC compliance is testing. Power supply manufacturers must test their products to ensure they meet the required EMC standards. This can include both conducted and radiated emissions testing, as well as susceptibility testing to ensure the power supply can withstand electromagnetic interference from external sources. EMC is an important consideration when it comes to power supplies. By ensuring EMC compliance, power supply manufacturers can ensure that their products function properly and do not cause interference with other devices and systems. We hope you found this episode informative, and thank you for listening to Power Tech. Join us next time as we discuss the latest trends and developments in power supplies and power management. Until next time, stay connected and stay powered up.